In this week's activity, I'm going to have you apply some of the topics we've been learning lately in a hands-on type of a way. I think that a lot of the topics we've been learning lately are difficult to fully absorb or fully take in without actually using them yourself. So in this activity, I'm just going to give you one opportunity to actually use these concepts and actually practice them in a specific situation. Basically, I'm going to have you do a simulation of planning and running an experiment. So you'll be planning and running an experiment without actually running it physically. And first, you'll need to open up a blank Google Sheet to complete the activity in. And after you open up your blank Google Sheet, just follow along with the directions that I give you in this Google Sheet that I have open on my screen. So I'm going to walk you through this one step at a time. And first, I need to explain this legend that I have over here. So it says bold, a copy text. What that means is that if I have something in bold on my screen right here, I want you to type it out exactly how it looks on my screen. So for example, in G1, I want you to type the words independent variable, and in E4, I want you to type level 1 and just have it say level 1. And over here, I want you to type level 2, and I think that's G4. Let me scroll over. Yeah, G4. And right here it says insert your own idea in italics. So if I have something that's in italics over here, um, that means that I want you to type your idea in that space. And the words I have on my screen are just a placeholder showing you where to type your idea. So for example, in G2, you're not going to be literally typing name of independent variable. You're going to be typing in your idea for the name of your independent variable. And over here, you're going to be typing the name of your first condition. So this is basically just saying type your idea right here. And so first of all, go to G1 and type independent variable. That's the first thing you should do. And before we move on, let me explain this situation or what this situation is about, this imaginary experiment. So I'm having you imagine that you're a professor who's teaching a class, and you want to test the effect of something on your students' exam scores. Maybe imagine that you have a midterm coming up in your class that you're teaching, and you want to test the effect of something on your students' exam scores. And it could be the effect of sugar, um, it could be the effect of sleep, it could be the effect of study hours or tutoring. Um, so I'm just having you imagine that you're wanting to test the effect of something on your students' exam scores. So in this experiment, your dependent variable is exam score, meaning you're going to be recording exam scores from your students. But I'm going to leave it up to you to decide what you would like to manipulate. So I want you to think of something that you could manipulate in your classroom to test its effect on exam performance. And so you could decide to test the effect of sugar. And if you did that, your independent variable right here would be dosage of sugar or grams of sugar or something like that. You would put that here. You could decide to test the effect of hours of sleep. And if you decided to do that, you would type hours of sleep right here. Or you could decide to test the effect of, let's say, study hours. And then your independent variable right here would be hours of studying. You would type that right here. So just think of whatever you think would be interesting to test if you were actually doing this for real. And then type the name of the independent variable that you're manipulating right here. And this is imaginary, but I want you to pretend like it's real and think of something that you might like to manipulate if you were actually in this situation. And once you've decided on your independent variable and you've typed it in right here, you're going to need to choose two levels of your independent variable to actually give to your students, your participants in your class. So if your independent variable that you put right here is hours of sleep, you would need to pick two specific hours of sleep, like 2 and 6, 4 and 6, maybe 1 hour and 5 hours. They can be whatever you want as long as um, you think that they would be appropriate to test. So once you, well, oh, or for example, if you wanted to test the effect of tutoring, your two levels might be 0 hours of tutoring and 10 hours of tutoring, or 5 and 15. But remember that the levels of an independent variable aren't always numbers, they can be categories. So, for example, let's say your independent variable is um, type of study method. Well, you could do that and manipulate type of study method, and then your two levels might be, let's say, um, studying in a group and studying alone. Those would be the two. Those could be two levels of type of study method. Or if you're independent, if you decide that your independent variable is, let's say, um, type of exam, you could have two levels being open book and closed book. So once you decide your independent variable, I need you to pick your two levels and type the name of your first level in this box right here, E5, and type the name of your second level in this box over here, which is J5. And remember that the levels are just the names of your conditions. So level 1 is name of condition 1, level 2 is name of condition 2. This first level is what the first group of students, the first half of your class is going to receive. Level 2 is what the second half of your class is going to receive. Group 2 basically is going to get level 2. So you're going to be having half of your students in this group and half of your students in this group. So once you've decided on your two levels, the level for group 1 and the level for group 2, I need you to put some participant ID numbers here. And to keep this from being too long, I'm just going to have you have 4 people per group. So that over here, put 1 through 4, and over here, put 5 through 8. And just have it look exactly like I have it right here, just on your own Google Sheet. So 1 through 4, your Google Sheet should say participants 1 through 4 over here, and 5 through 8 over here. And once you're done with that, um, fill in all of this text that I have here. So put extraneous variables right here in, I think this is E7. And then under here, put time of day, temperature, and testing time. And under here, put balanced, controlled, and controlled. And over here, put dependent variable and exam score. And over here, do the same thing. Put extraneous variables, time of day, temperature, testing time, balanced, controlled, controlled, then dependent variable, and then put exam score. Remember, if it's in bold, I want you to just type it the same, exactly like how it looks on my screen. Just reproduce it in your own Google Sheet. And now, what I want you to do is balance this the extraneous variable, control this extraneous variable, and control this extraneous variable. So remember, an extraneous variable is a variable that isn't being studied, but could affect participant scores on the dependent variable. So what I have right here, time of day, temperature, and testing time, are just 3 variables that could impact exam scores, but you're not studying these 3 variables. They're outside of the purpose of your study, which means you just need to take care of them so that they don't affect your results. And you need to prevent them from becoming confounding variables, which would affect your outcome. And to prevent them from becoming confounding variables, you need to either balance them or control them. If you balance or control an extraneous variable, it's going to be equal between your groups, and it won't be a confounding variable, and you won't have to worry about it affecting your results. For time of day, I'd like you to balance it, which means you'll need to just pick 2 specific times of day. They can be whatever you want. And I want them to be a number like 9 a.m., 10 a.m., 11 a.m., 1 p.m., 2 p.m., and type in those numbers right here. But for it to be balanced, what you need to do is pick one time of day, and put it in here, and pick another time of day and put it in here. So these 2 people get the same time of day. These 2 people get the same time of day. And then when you go to group 1, take the same 2 numbers and give the first time of day to person 1 and person 2, and give the second time of day to person 7 and 8. So basically, pick one time of day and give it to the 4 people in green, and pick another time of day and give it to the 4 people in blue. And that way, in group 1, it's going to be half and half, and in group 2, it's going to be the same 2 times of day, and once again, half and half. And that way, it'll be equal between your groups. So basically, over here, it'll be, well, let's see. I'm just going to use some letters as an example. So let's say AA, BB, AA, BB. That's basically what you're doing, but with times of day. And if it's so now I want you to think of a temperature that you would be testing people at in the temperature of the classroom, and I want you to control it. And if it's controlled, what that means is it's the same number for everyone in the experiment. If something is controlled, it never changes. So just pick one temperature and give it to all 8 people. So everyone in the experiment takes the exam at the same temperature, all 8 people. And testing time, I'd also like it for it to be controlled and never change, which means give all 8 people the same amount of time to take the exam. So just think of a number in minutes that they would have to take the exam, and put that number of minutes in here, and give it, type it in all 4 boxes right here, and type it in all 4 boxes over here. And after you're at this point, all of these boxes that I've just color coded are just going to be full of your selected numbers, of your data, but just following my directions. So like I said, you can use whatever numbers you want, but you can use whatever times of day, whatever temperature, whatever testing time you want, as long as it's reasonable, as long as it's realistic, and as long as you're following my directions for balancing and controlling. So just type those in. Once you get to this point, I want you to make up the exam scores of the 4 people in group 1. And type them in, and make up 4 exam scores for the people in group 2 and fill them in. And the exam scores need to be percentages like 71, 85, 95. not a number of points, but a percentage exam score. You don't have to type the percent sign, just type the numbers. Like let's say 95 or 96 like that, um, 88 like that. And you can make up whatever eight exam scores you want, as long as, um, well, what I'd like for you to do is take, when you make up each person's exam score, take into account the condition that they're getting, and also take into account the extraneous variables that are impacting them, and then make up an exam score that you think they might get under those circumstances. That'll make this a little bit more realistic. And you can, and also don't make sure that the four scores in group one aren't all exactly the same. It's okay to have a repeat, but you need to have at least some variability. And also, it's okay to have a repeat in group two, but also um, don't make all four of them the same. And once you're done with this, what I'd like you to do is calculate the mean of group one and the mean of group two. These are going to be your results. So actually, just type mean right here, and then type in equals average, and then calculate the average of group one. And then do the same thing over here. So just highlight the four values here, get the average. And then you're done with sheet one. Now I want you to move over to sheet two. And what I'd like for you to do here is actually just, well, keep the same independent variable and type it in right here. Keep the same two levels and type them in here. And so all of this is, this part right here should look exactly the same as it does in sheet one. And once again, type in all of the words that I have in black. So actually, all of this is just make it look exactly the same as it does in sheet one. Um, just you could just copy and paste it if you want. And and now I'll explain where things are going to be different. So now what I want you to do is um, once again, balance time of day. Once again, control temperature. And here what I'm having you imagine is that you're redoing the experiment. So maybe it's a new semester and you're teaching the class over again and you're redoing the experiment with a completely new group of students. And once again, put participant one to 4. Over here, put participant 5 to 8. And um, over here, what I want you to do is make testing time into a confounding variable, which means actually um, pretend like you're doing a bad experiment and you actually don't balance or control this variable like you should, and it actually turns out into a problem. And for it to become a confounding variable, what I'll have you do is give everyone in group one testing time, and give everyone in group two a different testing time, which means the two groups are being treated differently, and one group is getting an unfair advantage over the other one. And now it'll actually be a confounding variable because it's something that differs between your conditions. Um, it's something that differs between your groups other than what you're actually testing. And everything else other than this is the same. So when you do the balancing and controlling, you could just copy and paste everything from sheet one. So this could be the same 2 times of day. This could be the same temperature. That's fine. That's because the only difference I want is for this to become a confounding variable. And once again, make up your exam scores for all 8 people. Um, and don't use the same exam scores from sheet one. Um, make up a new set of 8 exam scores, and as you're doing that, think about the impact that you think this confounding variable would have on those exam scores. Um, and once you're done with that, the last part of this activity will be for you to create 2 separate bar graphs, one to show the results from sheet one, which was the good experiment, and from another bar graph for the results from sheet two, which is the bad experiment with a confounding variable. And I'm going to have you compare them and decide if you think the confounding variable affected the results of the experiment. And this will allow you to compare them. So the first result will be like a baseline. You can compare your confounded experiment to that baseline and see if the results seem to be skewed or biased in some way. Actually, the process of making a bar graph in Google Sheets is a little bit strange. I was having some difficulty with it. So instead of making the bar graph, I'm just going to have you do this. So over here, just put sheet one, and then here put the name of condition one. So this, I want you to just type this exactly like how I have it. That's why it's bold. And this, I want you to actually put the name of your condition. That's why it's italics. So type in the names of your 2 conditions. And then under here, put mean equals, well, whatever it equals. Type in the number. And then over here, type in the mean of your second condition. And then over here, do the same thing, but for sheet 2. So just make it look exactly like this, or at least roughly like this. And just, I want you to, what I really want to be able to see is that you can compare your results side by side of sheet 1 and sheet 2. So just on your third sheet, just use this format that I have right here and put the means of your first experiment over here and the means of your second experiment over here, just so you can have a side-by-side comparison like this. And then the very last thing I would like you to do is answer this short answer question, and it is Well, actually, two short answer questions. First one is, do you think, I want you to answer these two questions in sheet 3, and that'll be the very end of this activity. And the first one says, do you think the results of your confounded experiment look different than the results of your first experiment? So just a yes/no answer is fine. So look at these two results and decide if just based on your visual inspection, if you think that they look different. If the outcome looks like a different, would lead to a different conclusion. And if yes, if you think that they do look different, describe how the results changed after you included the confounding variable. So here I want you to um, specifically describe the ways in which this result looks different from this result. So if you think that the result in sheet 2 looks like a bigger difference between the means of the two groups, you could mention that. Or if you think that the difference between the means looks like a smaller difference compared to sheet 1, describe that and say you think the confounding variable shrunk the difference. So yeah, just basically describe the specific way that the confounding variable skewed the outcome in sheet 2 and threw off the results basically. And just put your answers here, and then that's it. And you don't have to type out all of this text. You could just put 1 and 2, number your answers, and then after that, download your sheet as an Excel file, and then upload it as your final activity, and that's it. Upload it to the submission link for activity 8.